Here we have Jeff. During the past grey winter, he indulged in his newfound love for food and cooking. Unnecessary to say that these new passions consumed so much of his free time that it deemed him no longer possible to follow his daily workout routines. Now, with the first warm summery sunbeams shining through the kitchen window, he wished he had not given up on his training. In a few months, he and his friends would be off to the sunny beaches of Tenerife, and he would prefer not to look like he enjoys food as much as he actually does. A month later, Jeff has not yet succeeded in his goal to achieve the perfect beach body. His desperation and frustration becoming more than obvious in the way he works himself to complete exhaustion in his evening workout routine. Having a drink after one of these energy-draining bouts of exercise, one of his friends took pity on him and explained that he would never start burning fat if he proceeded to exhaust himself. Being out of breath during the complete routine was not a sign he was burning fat, it was rather a sign he was burning carbs. And the 15 minutes he spent on the home trainer would hardly be enough. It would be way better if he would spend an hour on the bike, but at a way lower resistance. Jeff complained that he would get tired way too fast in order to finish that ordeal his friend was proposing. Maybe he should eat some Dextra Energy before starting the routine, came the advice. The glucose in there would be absorbed in the blood and give him some extra energy. No, that's not true, came it from another friend. Sucrose, as can be found in table sugar, would be way better. This sugar was built up out of two units, glucose and fructose, and needed to be split before being absorbed in the bloodstream. But since glucose and fructose were absorbed independently, this would result in a faster energy availability. It is not needed to be said that these conflicting opinions led to a dispute on the friends. Overhearing this argument sparked the idea for the experiment we are reporting to you. We looked into the oxidations of carbohydrates and fat during the aerobic exercise when glucose and sucrose are ingested, and to the resulting AQ. We did a research on oxidation during exercising. For this we used two participants. A third person wrote down the values of both of the subjects every 2 minutes. The participants had it eaten at least 8 hours before the start of the experiment. Thus, they were in fasting state. Furthermore, they had the same gender, approximately the same age, the same condition, and approximately the same body composition. The subjects were asked to cycle 30 minutes on a home trainer while wearing an indirect calorimeter. This calorimeter measured oxygen intake and carbon dioxide exhalation. It was the same, just as a resistance of 5 and the power of 75 watt. After this 30 minutes, the subjects took a drink. This drink consisted out of sucrose or glucose. 75 grams was dissolved in 200 milliliters water. The drink was taken double blind, so neither the participants nor the researcher knew what drink they were having. After this break, the participants cycled for another 60 minutes while wearing the calorimeter again.
The baseline measure of Irene gives an indication how the RQ is going, which is displayed in the blue line. It is a quite continual line. It is a combination of the oxidation of carbohydrates and fat, which are displayed in the orange and grey lines in the graph. The oxidations of fat and carbs mirror each other quite well. The same can be seen in the baseline measures of Eline. The strange peaks of carbohydrate and fat oxidation can be explained by Eline's foot slipping from the pedal, resulting in the slip of the mask. The measurements after the sugar intake indicate that Eline, who ingested glucose, leans a lot closer to the carbohydrate oxidation than Irene, who ingested sucrose. Glucose should be absorbed relatively faster due to the simple structure. There are a lot of fluctuations in the measurements, Irene having more than Eline. These could be explained by the sensitivity of the calorimeter or some small discussions that were held between the participants. The peak in Eline's measurement could be explained by typographic issue by the researcher.
Our findings suggest that the person that took sucrose stays longer and more prominent in fat oxidation compared to the person that took glucose. Since Jeff wants to burn fat, we can recommend him to take sucrose before exercising instead of glucose.